Alright, so recording started. Let's start. Alright, so before we start, do you have any questions for me? Good morning, Morgan. Actually, for a lot of people, it's night. Alright, so do you have any questions for me before we start? Yes? Do you have any questions before we start? Alright, alright, so yesterday we were talking about various kinds of joins. Again, a little recap. A little recap. The normal inner join is that only if one particular column or collection of columns are matching both the sides, only then you get the results. If you say left or left outer join, it means the entities on the left hand side is, here is the keyword, left hand side is A, right hand side is B. Okay? So on the left hand side, and you can use both, you can say, instead of saying left outer, you can simply say left. So the left, the entities on the left hand side, even if they don't have a corresponding matching entity on the right hand side, they will still come. So 2 Ryan came, even though for 2 there is no corresponding entry on the right hand side. If you say right outer join, so entities from the right hand side will come irrespective of whether there is a corresponding ID on the left hand side or not. Full means from both the sides. Full means all the distinct IDs from both the sides will appear as if it's a big union. Alright, this we talked about. Now, a question to you. It's a little teaser. So, what will be the output for this? The set A means 1 Sandeep, 2 Ryan. Set B means 1 Giri, 3 Saha. And when you say, okay, join A and B by ID and there is left outer, what will be the result? Anybody? It's a little teaser. Alright, alright. So it won't be that straightforward. So, yeah, look closely. We told that this keyword left outer join or left has to be before this comma in the middle, right? Therefore, 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 it would give an error to you. Alright? And the interesting part is lots of us actually make this mistake very often, and that's what discourages us from using left or right outer joins. Alright? Now again, join A by ID, outer join B by ID, do you think there is a mistake? Yes? Or do you think it is okay? And what will be the outcome? Yeah. So we have got A, we have got B. We are joining A by ID and B by ID, meaning the join is based on this particular key. So what will be the result of this one? 1, 2, and 3. 1, 2, and 3. That is full join, right, Puneet? So it's actually an error. Again, this is an error because outer cannot come alone. Okay. But left or right can come alone. Had it been left or had it been right, it could have been syntactically correct. But outer has to be either left outer, right outer, full outer. Yeah. All right. Good. Is everyone with me? All right. Now let's talk about this. So when you want first 10 records, you can say limit divs 10. All right. And it's just equal to your general limit command, where it will give you the first 10 records out of this. This is good for testing purpose. Okay. So a general strategy is to have this sentence somewhere in between. Okay. So that you, while running, you only churn 10 records. Okay. You only churn 10 records. Second is, second is here. Second is that you use a sample. Sample is something very new. Those people who have been working in statistics, the sample has been quite for there for quite some time. So sample essentially means that out of all the records, give me these many, this fraction of total, or this much percentage of total number of records. Okay. So when I say sample divs point one, it means point one fraction of the total, which is 10%, 1/10 of the total records, but it will be fairly random sample. Every time you sample, you'll get a new set of records. With fees point is this valid? Dump limits div. No, you cannot say dump limits because every single operation has to be a single transformation. Okay. And also, whenever you have doubt, you should try it out immediately on the console. Keep a pig minus x local open and keep trying all these commands, and it will tell you whether something is wrong or right. All right. So, any questions here? Limit is getting 10 records, while sample is getting you a fraction of total records, a portion of, a sample of, a random sample of your input records. All right, sounds good. Sample is always in fraction, not in percentages. Point 0.1 means 10%, 1/10. If you have 100 records, if you sample it, chances are you will get 10 records. Okay. In case you have 99 records and you are saying give me point 0.1, chances are you will get either 9 or either 10. Okay. So it has that much of a random sampling strategy. Yeah, dash dash is a command. So everything after dash dash is a command. All right. Any questions for me? All right. Now, a question for you. Read this script carefully. First sentence says divs equals load this particular file. We loaded that files into div. Second step is sample divs point 0.1, which means we got 1/10 records of the total number of records. And now we execute dump sum. Now, here we are executing this command dump sum twice. Will these two commands give separate output or same? Will they give the same output? Will it give the same output? Murugan says no. Okay? Okay. Okay. Roshan says different. Chandra says same. Okay. So, okay, Roshan says different. Murugan says different. And Murugan says, okay, perfect. So actually, it will give you the different output. It will give you a randomized sample of the total. Sounds good? No? Okay, why does it happen? Because lots of us. So, as I was telling you that, right, right. Right, that is exactly what I wanted to say. Sum, when I say sum is basically when we keep on saying things in pig. Say div load this, do sample, then do something else, and then dump. So the moment a dump is executed, every time, every time, all of the statements on which some will depend on which this particular data set depends will be executed. Meaning, the moment you say dump sum, so first it'll go to find there is something called sample and sample divs is this. So first it will this line will be executed. Whatever data gets loaded, after that sample gets executed and you get this. All right. So every time you say dump or say store, only then, only then various commands gets executed. By the time pig keeps on noting down that, oh, you wanted to mean that you div means loading this file. Sum means a sample of divs and so on. Okay. So pig just keeps on noting down and the moment you say store or dump, only then the execution happens. All right. Otherwise, if we had that this gets loaded as soon as we want, that means the results could have been far, far, far more different. Okay. Also, basically, this is essentially a batch process, meaning the whole batch, had there been 15 things, some said limit, some said here if we had say this equals limit, you know, some by 10, and then we had some, let me just, okay, so if we had this like this, and then we had sss1 equals filter some records by some column $0 equals, okay, so all of these things are just getting noted. Nothing is happening right now. The moment we say dump sss1, or only then these will get executed, all these commands. Now if I say, instead of sss1 saying, we say sss, okay, that means this will not get executed, only these three things will get executed. Okay, so this will have no effect. Pig will not do anything special with respect to this command. Nothing gets loaded, nothing gets filtered. Yes, that is correct, Puneet. So even though, okay, even though you are trying to say dump sss1, okay, so you're trying to do these two things. Now common sense would have said that when I computed the value of triple s, these things should be stored somewhere, so that when we dump this, only the last command should be executed. But it doesn't happen that way. Every trigger, every trigger, say for example, this trigger will dump ss1 will execute things in this order: load it, sample it, limit it, and then filter it. So it will execute the whole thing again and again. Right? Reason is simple, although it sounds like counterintuitive, but if you think about it, this data which we are talking about is, if we try to load it somewhere, we try to cache it, we try to mirror it, it does not make any sense. All right? It does not make any sense because the data is too big, and each step will result in new data set which is equally big. So if we try to copy and clone this data, that will be very impractical, right? So you got the reason, right, for this particular approach? Because for, if it tries to cache the state in between, say whatever is the result of loading or sampling, it tries to save it somewhere, compute it, and keep it somewhere, then there are high chances that you will end up having lot of data either in memory or on disk. All right. The Yeah. Okay. Are you not convinced, Puneet? And it's a very good question. Very good question. Okay, and all right. So now we have this. Okay. So parallelism is the basic premise of Pig. It's a basic promise provided by Pig to you. All right. Parallelism in various terms: on the local machine, on the multiple distributed way. So most of the distributed computing has come from parallel computing. Parallel computing means on the same computer you have got three processors and your work is getting executed on these three different CPUs, right? That is parallel computing. While distributed is you have multiple machines and you're distributing your code onto this. You are distributing your work onto these multiple computers. Now, so pig provides a keyword called parallel, okay, which essentially controls how many number of reducers you want. In most of the game, the only thing that is controllable from your side is number of reducers. Okay, so whatever parameter you give for the parallel, those many reducers will be created. For example, daily equals to load nysc underscore daily file as this, and after that we are saying group by daily by symbol and do it parallelly. So if you remember that group by will involve sorting, and hence there will be a reducer logic, and effectively when we say parallel, so 10 reducers will be created, right? Now, sounds good to you? So when we are doing this, every time we do group by, order by or something, we'll have to apply this keyword to define number of reducers internally. So pig, whenever we do anything and pay on pig, it basically creates internally a jar file containing all of this logic and then send it to MapReduce. Okay. And if you want to control how many reducers are there going to be for this particular group by statement, you can control that using parallel keyword. Right. So the number of mappers are basically function of how distributed your data is. Okay. So mostly in the data intensive operations such as pig, when you have input data that you need to churn, in those cases it will be very inefficient to have number of mappers lesser than number of blocks. Imagine having to transfer the data from one node to another, and how much data it is? 128 MB. To transfer 128 MB over the network is going to be a considerable headache every time. And that is why it is generally assumed that the user is not interested in customizing number of mappers. Although Hadoop's MapReduce component allows you to customize number of mappers, but Pig hasn't explicitly given a parameter to control number of mappers. Alright, now next question arises that when we said parallel 10, so does it mean that by default Pig only creates one reducer? No. Pig has something basic default strategy built into Pig. Okay, and how does it work? It tries to see the number of how much data are we trying to churn. Okay, it tries to figure out how much data are we trying to churn, and in that case, based on that input data, it creates number of reducers also. Okay, the way it created mappers based on number of blocks. Similarly, number of reducers are also created based on the size of input data. Okay, so per 1 GB, it one reducer. It creates one reducer per 1 GB, and it keeps on doing it until there are less than 1000 reducers. If you have got 1 terabyte data, that will create 1000 reducers, and hence, but it will not create 1000 reducers, it will only create 999 reducers. Okay, if we have 1 terabyte data, and if you divide by 1 gigabyte, that will be 1500 reducers, but 1.5 terabyte will have 1500 1 gigs, 1500 into 1 gig, and ideally should be creating 1500, but its upper limit is 999, so it doesn't go beyond that. All right, so you make sense to you? All right, now how many reducers will it produce? Can somebody tell me? Or let me ask you, will there be any reduce side code for this? Yes? No reducer. That is correct. There are no reducers. Now, next one is, does parallel clause have any effect in this? All right, that is correct. Also, I forgot to mention that in case you are having many group clauses and all sorts of clauses, you can just set a variable called default parallel is 10 or 5 or whatever you want to set. And by default, it will create that many reducers. Okay, great. So it will not have any effect. Reason being, parallel clause only control reducers, and when there are no reducers, then there is no point of having parallel clause. All right. Now, there is a command called flatten. Flatten is just opposite of what we had done in group by. Okay, whatever we did in group by is was just opposite of flatten, meaning converting a bag into different tuples is the role of flatten. Okay, so for example, Sandeep has the second column as bag. This particular row or this particular tuple has first value as Sandeep, second value is a bag which contains two tuples, one is C, other is C++. If we say for each of this record, for each of these, generate name and flatten languages. Okay, this will basically generate something of this sort. Are you okay? So if we have a file, let's say flatten test. I'm trying to do it locally. Hmm? Now, if we say pig minus x local, let it load. So my file is load flatten test, and if I say dump f, what did it say? It doesn't seem to work here. Nobody's. Let me just log into the server. Okay. Now we have like this. Okay. Let me start pig. So I say f equals to load a file called flatten dump f input. Oh. So copy from local flatten into ASCII and let me load it again. Alright, so it is loaded now here. Now the next thing we'll do is we will flatten it. We will say here there's a little difference. We have not given any name to it. What we can do is we can actually do it the way we have already done. So we say load flatten as name and languages. Language is a bag of tuple containing P, and we can further specify P as char array or something of that sort. It is absolutely up to you. Then we iterate over x, and for each x we generate this, and we dump p1. What's going on? Input path does not exist. Okay, I got it. Input path does not exist because we need to refer it from here. So you can see that it has converted our bag into separate tuples. Are you clear about this? Great. And whatever we have done just now, we have created this P. If we say P2 equals group by group P1 by, we have say describe P1 and group P1 by name. Alright. And then we dump P2. Any questions on flatten? On flatten is just opposite of group by. Now you can see P2 has become this. Whatever our input was here. So if we say that we have a group by from here, if we group by from here on the name, we'll have this. Okay. We can further clean it up. We can further clean it up. Like we can for each, and then while grouping by, we can say out of this we can say uh, project only the second one, and we'll have only those things. Okay, that is very much possible. All right. Now, generally, whenever we are building something, whether in any newer language, there will be a lot of legacy code lying around, or there could be a situation where you need some function and that function is not there in pig. For example, doing the summation of character values. Okay, if you have to sum up the character values of a string, there is no such function in pig. All right. Now, anything you can do it in Java, you can do it using pig. Pig allows you to do that. So Java built-in type you can call straight directly. All right. Say for example, there is a function called integer dot to hex string. In the class called integer, there is a function called to hex string, which basically converts. Yes. So output what we have got is a complex object here. It's a structured data because we know pig knows here which are the fields and what is the value in those fields. Okay. If you here say describe P2, it will tell you that it knows what it's talking about, right? P2 is a group. P2 has first column is a bag, okay? Is a bag of things where the value is first column name is group, it has got a value. Then there is a second column name whose name is P1, and this P1 has got a bag further. It's a bag of name and languages. Okay, name and P, right? So it knows. So basically, unstructured does not mean unrelational. Unstructured essentially means that we don't know what is there in the input. Or structured data does not always mean that the data has to be in the format of relational database. A JSON data is fairly structured data. Now, Chandra's question is how an end user is going to use this data. Okay, so generally what you do is you prepare this data, save it as JSON or something, and send it to your, a central place from where you can serve it to the end user. These tools are for analytics. Okay, and you might display this user the data in the form of a tree, in the form of a table, in the form of a graph, in the form of a map. All right. So you may not be necessarily displaying all the data all the time in the form of a table. So effectively, tabular data may not necessarily be always required. Okay. What about data types? It is showing you the data type. This one is byte array, this one is byte array, this one is byte array. If we had specified clearly in the beginning that this is string, this is string, this is string, then then pig could have been far more clearer about about the data type. Okay, so you can assume right now that it is sort of a semi-structured data where pig does not know much about data types. Yes, we can do casting between the different data types. So while you are doing for each, and the way we were saying here, I'll show you this. So this is what it is. You see, we are casting here. All right. So here, what we are trying to do is in the Java built-in types, first we created a function called hex, which is basically referring to a Java function. Java function name is integer.toHex string, which takes an argument called int and returns a hex value. Returns a hex value which is a string. Now, after loading the data from NYSE, what we do is we do for each divs generate this comma hexadecimal value. What is hexadecimal? This is what we created just now in the first line, and then we pass the that particular column, and we also mark casting here. Even if you don't do casting, pig tries to guess the data type very comfortably. Okay. Now the next one is this function which we tried to use existed in Java but did not exist in Pig. So what we just basically bridged it. In the similar fashion, there could be your own library, your own function which does not exist in Java standard library or which is not part of the Pig's standard library. So those kind of functions also you can use inside your Pig code. But first, you will have to create a function, register your jar, and then define your function the way we have defined earlier, and then start using that function easily. Okay? Then start using that function the way we started using hex. All right? Yes, it's extensible, it's flexible, so that tomorrow you are not locked inside the pig script that oh I can't do this, I can't do that in the pig script. So we are going back to MapReduce. So here this is how we are registering. So you create your jar, put it in a folder, and then say register whatever jar you want to say. Okay. So I think I had pig UDF. Okay. Any questions? So here is my pig jar which I can register. Yes. So whatever library external libraries are in the form of again Java code. You will have to compile them and then go to pig and say in the same folder you should just same local folder I've kept a file called pig UDF. I'll say add jar pig udf.jar. not add jar. Oh, add jar is in Hive. I'm confusing it. Here it's register. So it got registered. All right. Now we can use the function which we have defined over there. Sounds good to you? So there could be a scenario where you have a traditional script which you want to use inside Pig. Let's take a case of let's take a case of what? The let's take a case of a company which is having a Python function and it's running fine for years in their production. Basically say there is some internal function which takes a value, translates it into something. Now, it would be very impractical to it will be very impractical to convert that function into Java or create a UDF. Okay, create a UDF. Instead of that, what you do is, all right. Now, all right. So you register your file, say for example your Python file, and then you can use the function in that file called say for example production, and then you can iterate over that. Okay. This is basically streaming your data through an existing function, just like Hadoop streaming. So let's take a a demo. The project is available here in case you have not used it. So you can download the pig project. It's basically a Java project, and I'll demonstrate to you how to use Java project for in case of a pig. Now in the pig UDF, you can see the definition. There is a function called upper. Okay. So when you are defining things in Java, you are trying to create a standard library of pig. Okay. Now, this is little different from what we had done here. Here, we had some jar containing a function. We just used it. That was not really a pig UDF. Here, we are trying to create a standard function in using pig. So we write this for each function. We have to create a class, and inside this class, we have to create a function called exec, and the input to this would be a tuple. Okay, and then you basically go through the tuple and then take some action. Here I'm just converting it to uppercase, and that's all right. So I what I do is I'll just do a export. Okay, export, and I say jar file, and I also say that keep it the name as pig.udf, and there I go. It's done. It is done. And then I say scp and download pig.udf, and I'm copying it to Hadoop 1.nobigdata.com, and under that under that I'm copying it to say data folder. Okay, so I'm copying this newly generated jar into that place. So you can see, looks like it's pretty big file. Yes, are you with me? So we copied this file now, but and let me exit this. So ls minus l, it shows that March 14 is the date where we when we have updated. It is, wow, it is 10 MB file. This is strange, and it is just one file. Anyway, because it has bundled other reference libraries, so we can say register register pig udf dot jar. That's all. Okay. Now we when we created a function called upper, now we can start using that upper. Okay. Now we have xyza. So what is xyz? It has nothing. Where was that file? Inside skd. Yeah. So here is that file. Now let me try to execute this. So load this. I loaded that xyz a data. What does it have? xyz.txt. It has nothing. Nothing much significant. And all I want to do is, after loading it, I'm going to generate this and dump b. Alright. Now it should convert it into uppercase. Is it clear to you? So whatever name we have here in the namespace here, my UDFs, that's the namespace we are using here, and then we are calling that function. Okay. So basically, you can actually create your own function, and now it all depends on against what this particular pig has been compiled. Now you can see our data got converted into uppercase. Alright. So I'm trying to answer Morgan's question, which version of Java it supports, up to 8. So it all depends on what version of Java has pig been designed. Okay. If if you have compiled pig in, I mean pig by default pig is compiled in Java 6 probably, so it won't run on Java 5 or Java 4. All right. So, and the version of Java does not matter. The version of Java in which pig was compiled does not need to be the same as the version of your local machine. Yes, if required, you can simply download it and do a Maven, and then whatever version you have, it will compile in that one. Okay. But as a thumb rule, any of these companies who build these tools, or even if you are building something distributed, I mean, something to distribute amongst people. You want to ship to lots of customers. You always make sure that your tool is compiled in a very low version. Okay, if possible, try to compile and keep everything in Java 5 or Java 6. Okay, that's a general psyche, because your if pig compiled in Java 5, it will run in all the versions above Java 5, but not the vice versa, not the opposite. Meaning, in case you compile Java pig in 7, it won't run in Java 6. All right, good. Any questions for me? So here we talked about streaming using Java built-in function, how to create your own Java function, how to create your UDF. Now the next step is the streaming part. Just like Hadoop streaming, we have pig streaming, meaning through we can stream our data the way we did Hadoop streaming via a new function of our choice, or we can stream our data through our program. Okay, now say for example you have a Perl file, and here again the way we had all kind of programming support in case of MapReduce, here it's the same. So if your function is in Java already available but it's not in pig, you use Java built-in type this way. If you have your own function in written in Java, then you can use it in this. If your function is written in Python, you can use Jython here. And in case your function, you really want a perfect UDF function, you create your UDF. This is a longer work. First you have to create a project, create a class, extend something, and then and after that you have to compile it, create a jar, ship it to the server, register there, then use. So this is a longer one, but it's far more stable. Now the last one is streaming, where any binary, not only Java or Python, any binary can be used as a function. Okay, any binary or script or any command that works in Unix can be used as a function inside pig, just like Hadoop streaming. All right, so we have this. We loaded NYSE dividends. After that, we say stream our data through this command and note the backcodes. Okay, what does this command do? This command takes some input from standard input, gives output to the standard output. So whatever is there in the divs is given to high divs.pl as standard input, and then it will be printing it to the output and will be saved to high divs. All right. So any command, whether Perl command, shell command, anything can be used as a pig function. Okay. The way we created SED combined with unique and sort, similar way we can also do it here. Sounds good. And also note the backquote. Backquote is something just before your numeric 1 key. Just before the numeric 1 key, you will see the backquote. This is not single or double quote. The reason is, if the backquote is used because if your program is taking some command line argument like hide, and we say minus x something. Okay, so this program, if it is taking input we, from the command line argument, we can provide that using single or double quote. Okay, now imagine that if it was in double quote, the pig will get confused and we have to again quote unquote things. Sounds good to you? Now there are chances that whatever program you are trying to run, it's not already installed on all the nodes. In those cases, you need to ship it. And to ship it, you define like this. Define your command like this. Okay? With some argument, this is minus rxyz is the argument for your hidiv.pl, and we also mark that please ship it to all the nodes. Okay? In those cases, we don't have to worry too much about any of this. Okay, it'll be copied to all the nodes. We'll have a function on all the nodes. We can use that function in our piglet, and you can see that. Okay, you can see that we are using that sort of a function. We are streaming our data through HD, and this is the input we have provided, and the output is what we get here. All right, is that everyone with me? All right, so only Morgan is with me. Yeah, so Chandra is also okay. Prithvi Puneet, good, good. And Roshan and Rohit, are you there? Rohit is offline anyway. So, all right, all right. So Roshan is not there. All right. So we talked about how to use various kinds of program or function inside your Pig script. All right. Now, whatever you are trying to do, there are chances that somebody else might have already done it. Have a look at the piggy bank. In the piggy bank, people keep on uploading their software, make it available over there, and then you can use that. The only catch is, okay, the only catch here is, let me see. I'm trying to see. There was a list of all the, so piggy bank used to be there. There's something called piggy bank in which lot of people keep on contributing. Lot of people keep on contributing and adding their source code. Okay. So for example, piggybank.jar might contain a regular expression here. So lots of people keep on. Yeah. You can see CSV loader is there, DB storage is there, fixed width loader is there, JSON metadata is there, and okay, isn't, is long. So there are lots of functions are provided by lots of people. Say for example, statistics. You can have correlation, covariance. Alright. So generally you basically download the file, and the way we created our own UDF by compiling it and creating jar, registering that jar, and that's all. Okay. Any questions still here? Under contrib, there is a piggy bank. Okay, so piggy bank is a place where people keep on contributing the various modules, and you can use those modules in your program. Okay, you can see there are the various utilities of various kinds: math utilities, statistics, decode. There are various utilities available as part of the piggy bank. Yeah, it's a global repository for the community. All right, now that was piggy bank. Now there are few more things which need to be taught you. One is for each nested. Wow, actually the code thing has extended quite much. So sometimes when you are going through for each, when you're trying to do for each, generate alone does not suffice, because you might have to do a lot of things inside generate. For example, look at this problem. What are we trying to do is, for each for each city we want to count the distinct name of people. For each city we want to count distinct name of people. Now if we go through the general way, it would be very difficult. We might have to do for each multiple times to reach to that level. So again and again, we will have to keep on doing for each till we first we'll have to compute distinct, then we have to compute count, and then okay. So there will be two multiple step process. Instead of that, there's something called for each nested. So we say for each my group, and then you say that compute distinct of all the names, and after that you have the generate. So basically instead of having a single generate statement, we made it a full block of code, and inside this block of code other commands, filter by, distinct, order by, and all of that can be used the way we have used distinct. We can use that on all the values of a group. All the values for a key are grouped by this command, right? And when we are iterating for each of the values, for the whole tuple, we can run this. Okay, so basically when you have multiple things to do inside for each nested is a great option. All right, so what we did, we computed the distinct names, and then we generated the counts. All right, good. Now there are we talked about various parts of the pig. We talked about the basic syntax. It provides basic syntax, joins, and everything. Then we talked about flexibility, how greatly pig is flexible. Before that, we talked about it can handle various semi-structured, unstructured data, and the complex data types. Now, the performance is the inherent part of pig. Pig's basic philosophy is is about mainly performance. Okay. The only reason people would like to use pig over other components would be the performance. And it gives you knobs, it gives you various controls to control the behavior of MapReduce. Okay. Earlier, we talked about how it provided you a keyword called parallel. Okay. It provided you a keyword called parallel, which basically made it very, very fast by giving us a control over number of reducers, right? Now imagine this, we had one big file containing names of millions of people. Now what we want to do is we want to translate name and country. So we have one big data set. Where is country misspelled? Oh, you are right. So here, CONTRY. All right. Right? All right. Okay. So what we are trying to do is we have a big table containing name of the person and country they belong to. We want to translate it into name of the person and ISD code. For that, we have another table containing maybe 100 entries for all the countries. And so on one hand we have a billion entries. On another hand we have maybe 100 entries. Now we are trying to join this. Now while we are trying to join this, these 1 billion entries will be sorted and this country code will be sorted, right? And this might take a long. While we have no intention, we don't really need the sorted list of these 1 billion entries. All we want is we want to translate the country into code. We want to translate the table on the left hand side to name and the country code. All right. Now, if I give you this task as MapReduce, what will you do? You will take the right hand side table, load it in the memory on all the data, all the task trackers parallelly. All the maps itself will have a copy of the right hand side, because it's okay to keep this 100 entries in the memory. We can simply keep it in memory and there will be no issues. So we don't really need a reduce for this. This is map side join, right? This is a map side join, meaning we have this small table, we load it into the memory, and while we were going through these records one at a time, we did the translation. Okay, we did not have to rely on reduce to bring it together. Okay, because we can just do it in the map side. We keep on reading one row at a time and keep on looking up in the memory that what does this country mean, what is the country code of this country. All right, and that we print it out without any reducer, and we also mark that we don't need sorting, so still we'll get the perfect results. Okay, so this approach is called fragmented join. We just say that mark this right hand side table as replicated, join persons, this is persons table on the left hand side, with CC, this is country code. By country we join these two table on country, and on the right hand side table we say using replicated, meaning using replicated. Why? Because we are forcing the replication. For faster processing we are forcing the replication, meaning this whole table, country code table, will be copied to all the nodes. Okay, or you can look at it this way, it will made part of the distributed cache, and task trackers will pick it up from the distributed cache, and as and when various mappers are reading the data, they will keep on translating using this in memory hash table, this in memory key value pairs from, and what will it they translate to? They will basically take up your country name into and convert it into code. So is this clear when we use fragmented joins? Yes. So in case your countries grow suddenly into 1 million, then you will have to rewrite this code. So here it's safe to assume that countries are not going to become a billion, and at this entries it is okay to keep it in memory. All right. So generally you take that call. Now the first optimization was our parallel keyword. Second optimization was fragmented joins. Now third optimization is when there is a skewed data. Okay. For some of the values, for some of the keys, there are too many values, and for some of the keys, there are nothing. In those cases, we say that our data is skewed. Some keys have so many values, like a billion values, and some keys have hardly 10 values. In those cases, we say that, hey, our data is fairly skewed. Okay. And to handle these kind of situations, if we try to do the normal way, it will be fairly inefficient. Instead, you should tell pig that, hey, our data looks like heavily skewed. Okay. And pig will try to optimize the whole pipeline. Pig will not try to load the data into memory. When you see skewed, you means the physical data distribution. Yes, yes. So imagine this. We have city name, city name, or how should I say? Okay, yes, city name and names of people. For some, the names of for some there will be 1 billion entries, 1 million entries. Okay, for some it will be just 100 entries. There are some cities where there are only few people and so on. Okay. So when it comes to skewed data, most of the optimizations fail badly, and you need to inform pig in those cases so that it does not try to load the data into memory and does not try to guess based on various number of things. Now all you need to do is whichever data set you think is going to get skewed by this particular uh, column. When I say user by this, and when I say skewed, meaning around city our data is heavily skewed. In this table, for one city there are too many records, and in this table for few cities there are too few records. Okay, that's how we define skewed. All right. Now, next is joining sorted data. All right. So, what was the command we have talked about earlier, which merges your sorted data? The Unix command which merges the sorted data. Anybody? Merging and sorting using sort command is okay. But if you have list of two data sets, and you want to merge them, and both of these data sets are already sorted, what command do you use? Anybody? All right. So let me ask you a little different question. All right. So if there are a number of records, sorry, there is a data set containing 1 million records, and sorting A takes about 10 seconds. Now, sorting the sorted A would take how many seconds approximately? If the data set which you are sorting is already sorted, so just give me an answer with the algorithm if you know any. And what does the common sense say? That if my data is already sorted, if you try to sort it again, how much time will it take? Anybody? Yes? Yes, Puneet is right. So it will take the same time. And you will be surprised that the initial version of binary search tree took enormous time in case of sorted data. So basically the binary search tree initially when in the first version took very had the bug that in case the data is sorted already, it is going to take a huge time. All right. So basically what am I trying to emphasize is all the sorting algorithms are fairly none of the sorting algorithm basically performs great on the already sorted data. So and even to figure out whether the data is already sorted, it would take the same amount of time as it takes to sort the data. Okay, almost the same amount of time. So there is no point in first probing the data that whether it's sorted or not and only taking that call. Therefore, it is up to you to tell Pig that hey, my data is already sorted. Do not touch it. No, it's not 50%. It's equal time. So it is better. There is no way to figure out mathematically. There is no optimum way of figuring out whether the data is already sorted or not. Therefore, in case your files are already sorted and you're trying to join these two files which are already sorted, it makes more sense to tell Pig that these files are sorted, just merge them. Do not try to resort them. Okay, and merging two files which are already sorted is a simple task, right? We had given you a demo in which there were three rows, people were standing in the queue, right? So it makes a lot of logical sense to utilize the pigs merge feature. If the dataset called daily and the dataset called div, they are already sorted on the key on which we are trying to join, it makes sense to merge them instead of joining them. I mean, it makes sense to just use a keyword called merge so that pig does not try to sort it before merging. Make sense? All right. Now let's take a 10 minutes break and back by 9:44 a.m. IST. Okay? All right, so let's start now. I'm back. Should we start? All right, so everybody's clear about when to use skewed, when to use merged, and when to use replicated, and when to use parallel. So parallel, skewed, replicated, and merged. All right. So parallel you use when you want to increase the reducers. Skewed you want to use when your data on which you are joining is has big variance in the values. Replicated if the tables you are joining, one of the table is very small, so replicate one of the tables. Merged you use when your data is already sorted. Yes. So there are a lot of times when you know more about data than pig can ever know. You know your data more than what pig knows. Okay. And you can utilize that knowledge to improve the overall time. All right. Now the next point is there is something called co-group. It was lot of times it was observed that we people were doing order by and joining on the same columns. People were first joining two tables and then order by on the same column. So for that, the order by and join was combined together to form co-group. Okay. So co-group is essentially first joining them and then grouping them. All right. So you can see that we say co-group this table and this table or this data set and this data set by animal. So cat means here you can see that cat means Alice cat, Adam cat, Whisker cat, Paw cat and all of this, right? So Alice cat is one and Adam cat is one. So that is a part of grouping and then there is a joining. All right. So this way, basically, in a single shot, we are joining and grouping, and that also means that if you remember correctly, so if otherwise you'll have to group by X will result in sorting of data, group table by column, sorting of table by this column, right? Now, if you are joining this table with some other table by the same column, in that case also, the sorting will happen again, right? Now, joining and grouping, if they are on the same column, there are high chances that you will end up doing sorting twice, right? Therefore, it makes a lot of sense to combine the two operations together, or in this case if you have already sorted by doing a group by or order by, you say that please merge it rather than joining it directly. Okay, so this is a next step of optimization where when you have to do grouping and join together. All right, now the next phase of pig is concatenating two data sets. If you have remember the union command in most of the data sets. What we do in union is load one data set, load another data set, and then compute the union. And what does union do? Union is equivalent to printing all the rows from one and then printing all the rows from another file. Okay, so that's what is union all about. And so union essentially just print simply all the records from A, all the records from B, and that's it. But in case you want to enforce an schema, then you can do that. For example, column A has some data. Let me find out. There is a table called A and there is a table called B. There is a nice table called B. Alright, let's just copy it. Hadoop CPA, Hadoop FSCP A to our data folder. Copy from local. File already exists. Let's ignore that part. Now let's go ahead with B. File already exists. Okay, pig cd data, and we have A and B already. A and B. Now what we want to do is we want to union these records A and B. Okay. Now let's have a look at what we want to do. Let's load A and B. Okay. Now we have got describe A and describe B. So A has got two columns XY, B has got Z and X, right? If we simply say C equals union A and B, what will happen is how many columns will the C has? Can anybody tell me quickly? How many columns will C have? 2. Perfect. So it will have only 2. If we have D equals and we say union on schema, we are trying to union by enforcing a schema. So it will try to fit in the same columns together. And can somebody tell me how many columns will D have? A has XY, B has Z and X. How many columns will D have? Perfect. D will have 3 columns: X, Y, and Z. Alright. Now let's see what does C have. Alright. So when we print C, you get 2 columns and all of the records as is. But when we say dump D, what do we get? Alright. So basically it'll have 3 columns X, Y, and Z, and it does care about the column names. Now you can see it has tried to fit the data on top of each other. Okay, it has got three columns, x, y, and z. For x, we have got values in the first one. Okay, describe d. So for x, we have got values in all the both a and b, while the y does not have a value in b, and so on. So pig does not care about column names in C. It did care, right? It did care. That's how it tries to put one data set on top of another. Okay. So, okay, let me copy it somewhere and that'll be better. This is our D. This is our dump D. Dump D gives us this, while D gives us this. Now let's have a look at C. So C was this, dump C, and there was a thing called describe C. Describe C. Alright. Now you can understand what I'm talking about. So when you say C has got two columns, D has got three columns. D is on schema union and C is non-on schema. Okay. So when you say on schema, it basically creates the all the possible columns, distinct set of columns, and then try to fit the values in these columns. Chandra, are you clear? Is everybody clear on schema join? Yes. So simple union without on schema doesn't care anything about column names. If that is what you meant earlier, then you are right. Okay, okay. Yes. So union in normal union in pig. Yes, you are right in that case. Yeah. All right. Is everybody okay with the union and on schema union? Any real-time example of union without schema? On schema union is good, but Punit's question is, can we have a good example of union without schema? Right? Now, if you remember our voter and votee example in the fourth session, where we basically kept everything into a single place, right? Even though basically we merged the two data set as is. In those cases, I would prefer non a simple union, right? If you remember our voter and votee example, so we had voter and we had votee in one. This was our table one, and we have table two, where we had voter and its value. Now we could have simply created table 3 equals union table 1 table 2. That is 1. Okay, Chanda is saying, let us say you have a data dump from your table from 2014 and you have data dump of the same table from very good, very good. Thank you, Chandra. So yeah, that is one good way to look at it. So imagine this. All right. So I think Chandra is trying to answer your question, Puneet. Yeah. All right. So did I make did that answer? Yeah. So good. All right. But um, but most of the time it is most of the time in case of structured data it makes sense to go for on schema merge, on schema union, and in case you don't have a structured form, you want to just bring this data together, you can go for union. Yes, yes. So on schema merge is really useful when your data, the columns are in different order in the two data sets. That's correct. Thank you, Chandra. Now let's move on. Anybody, what will be the result quickly? We discussed it yesterday. What will be the result of this one? Yes. C equals join A comma B. Yes, it's an error. Unlike in our SQL case where we say select star from A comma B, it prepares the cross product. That's not here. We don't have it doesn't work that way. There is a separate command called cross product. Okay, there is a separate command called cross product. So if you want to do a cross product, say cross cross A comma B, okay, and we say dump E. So it should be, what should it look like? Anybody? How should it look like? A and B cross product? What should it look like, the output of our A and B? A is same what we talked about earlier. So we have got these two sets and we are doing cross product. So what will be the result? Yes, it will be. So for each record will be multiply against every record. This is our A, this is our B, and A cross B, A comma B is quickly A11. So we take the first row, paste it here, and again paste the same row, pick up the these two. Okay, let's just paste it. This will, I got an idea. All right, now you can see this will be one. Okay, and another would be, this is what we will get. Ouch. All right, this is what we'll get. Let me turn off and turn on the screen. Now is it changing? So this will be the cross product of these two records. Okay, and that's what it will also show. This is what we got, right? So basically we took first row and put it in front of other rows and so on. Okay. The only thing is it will merge the tuples rather than creating this way. So it will look like this, not like this. It will not have these brackets. Instead, it will be comma. Okay. So is cross product very clear to you? All right. So now the usual reporting stuff. When you have a pig script, you can run that pig script from command line, and every time you run a script every day, you might want to change some of the parameters, such as the starting date and ending date of the report should be based on current date and that you would like to pass from outside. Okay. In those cases, it is very useful to have a parameter substitution. For example, in this command, you see yesterday equals something something, and then there is a variable. This is the parameter. This is the variable which has come from the parameter. And how do you pass this parameter? So once you have stored your command in daily.pig, you can execute daily.pig by saying pig daily.pig. And if you want to specify more parameters, you can say minus p date equals something. So this way, you are able to change the date without changing daily.pig file every day. Okay, every day without changing daily.pig file, you are able to pass a new value into that variable called date. All right, sounds good to you? Yeah. And second is when you have these lots of these parameters, then you might want to create a separate file in that you put all these parameters with somebody changing and running it every day, and you can pass that parameter file using minus param file argument. All right. Now, all right, is that clear to you? So earlier we talked the next step in optimization is loading of the data should be done properly. Let's imagine that there is a huge web logs in which there are logs of all the time. Now you want to process and you want to split these logs. Okay, you want to split these logs. One way to do it is that let's say we have logs equals to, okay, so we load logs, say, three times. Okay, logs 1, logs 2, and logs 3. And on each of one, or let me say we want to just load it once. Okay, and we want to say logs 1 equals to filter logs by some parameter, and logs 2 is filter logs by some parameter, right? And so on. This way we can create multiple legs out of the same log file, right? A better way of creating the same thing is using split. So you load all of this into one variable and then you split it based on this particular syntax. And this will basically generate three different copies of the data with only certain amount of records. So we have April 1, and this will be for the records where timestamp is between this and this. This will be for the records where timestamp is between this and this will be the record where timestamp is this. All right. So you will have three different timestamps. You'll have three different variables. All right. So this is another way of splitting the data. Okay. So here you can notice that one record can go into multiple legs. So out of W logs, we created three legs: April 01, April 02, April 03. And here you can see that it says that for all the records which are lesser than 4th of April, put it in April 03. For all the records that are there in after lesser than 3 April and greater than 1st April, okay, those records go into this. So greater than 31st March and lesser than this, which means April 01. Okay. While if you can notice this, we have ignored all other data about March, about February and everything. Also, we have data common between April 02 and April 03 because April 03 contains all the records before 4th of April. Okay, this is a good way to split your data into multiple legs. Although the performance will not be very significantly different from what we are doing here. Okay, we could do the same thing, exact same thing using this. Let's say if I have to do the same thing, what will I do is load will be load this, okay, load my file, and then we will have filter wlogs where timestamp is this. Okay, now like this. All right, this will also create you three different data sets. Sounds good? There's not much of a difference between this optimization and this step, and you can again say the same thing whatever you have done here and it'll behave exactly the same manner. Okay, the benefit of this approach is that even though there are three different splits, it will be done in a single mapper. Okay, it'll be done in a single mapper. Here it will not be done in a single mapper. All right, so that is how you create multiple legs out of a single data, and that's what is demonstrated here. Okay, we took a record, we split it into multiple pipelines, and then okay, so we took a record, we split it into multiple pipelines, and if we try to use it. Okay. And also notice that one single map can combine multiple values, and pig tries to do a lot of optimization at this point. Okay, nonlinear execution means that it's not like your C program that whatever instruction it encounters, it will execute it. The execution will happen in the reverse manner. So, for example, when we try to do store this, it will only execute this and this. Okay, it will not execute this and this. When you store this, only then these are going to get computed. This and this will get computed. Okay, so that is what we call non-linear execution. Unlike your C program, right? So that's pretty much about pig. That's pretty much about pig. If you have any questions, let me know. The general documentation is available here, and we are using 0.13, I think. Okay, pig minus version. Yeah, but it is little old. It is 0.12, but that's all right. Yeah, there's not much of a change. All right, so that's pretty much about pig. So we could do almost everything using a pig script. Any questions? Puneet, Prithvi, Chandra, Roshan, Murugan, Rohit. Any questions? Yes. All right. Do write to me if you have any questions, or we can have discussions in next session. Okay. Now I'm moving on to something called Hive. Is that all right? All right. Little about our LMS, a little bit, because there has been some things I've changed. Okay. So here, if you go to 21st February one, okay, okay, no worries, no worries. Now here you can see this, that this one I have merged, I have removed March 1st. We have marked March 1st as a holiday, the day when there was a, first we forgot to do the recording, and we also could not, I could not continue after 1.5 hours. Okay, and right, so I merged that, removed that one. So now we are essentially here. That is today's class. Okay, the Pig Latin continued and Hive Basics and 15th of March. So we are on the right side. Okay, so just after removing one session, everything is on the, on back on the track. All right, which essentially means that the session 11 might go up to April 4. Okay, I'm hoping that by session number 10 we should be able to cover up everything. If there are more questions, we can go up till session number 11. Okay, we'll see as per the situation. Okay, so which means there is a shift by 1 week. Okay, and most likely whatever we have to cover in Mahat will be covered before than that. All right, now, so that was a little change. Cool then. So let's start with Hive. Okay. All right. So the value proposition of Hive is similar to what we have in Pig. Hive gives you a way to write SQL, and it internally converts that to map and reduce. Okay, it internally converts that to map and reduce. So whatever SQL you write, it will be run by Hive. Internally, it will create the jar of MapReduce, upload it to Hadoop, run it there, give you the result in the tabular format. That's what Hive does. Also, Hive is an analytics tool, which means it's a read only. It's a read only, and therefore it does not provide you syntax of insert, syntax of update, syntax of delete. Okay? Insert, update, delete is not there. It's only retrieval. Out of CRUD, it's only the retrieval part. All right. Now, the value proposition of Hive is very simple and straight. There are a lot of people who are very much trained in SQL, and there are a lot of data and code already written for SQL. It would be impossible to transfer them or ask them to migrate to something like Pig, okay, which is a newer language. That is the reason why Hive exists. Now, as compared to MapReduce, it's very simple that Hive gives a very big abstraction over the programming. It hides lot of intricacies of MapReduce. MapReduce on one hand is even difficult for even developers, so MapReduce was not suitable as the analytics tool. So lots of work is actually done either in Pig or Hive. So Hive is very well suited for data warehouses. Hive is very well suited for data warehouses. And when you have relatively static data to be analyzed, and also when you do not require fast response, because at the end of day, Hive basically creates MapReduce, and those MapReduces are executed by our MapReduce framework, which means that Hive is also sort of going to take a longer time. So when you don't require fast response time and you have a data warehouse, you are trying to analyze a relatively static data, then then it's good to go with Hive. Also, it makes it possible to port the existing products onto Hive. Imagine that you have a humongous table, and on the top of the table, we have already created reports. In those cases, Hive is good. You can just take the queries from those reports and and basically migrate those tables into HDFS and start using the same reports by adding the Hive driver instead of JDBC driver. Okay, so if your data kept on growing bigger and bigger every day, and your one machine lookup has become very difficult, in those cases move the data to HDFS, create a similar table in Hive, start doing the processing execution of queries using Hive. Okay, the SQL dialect which Hive provides is fairly generic. Okay, because it has the data type definition from all kinds of tools, which means that it will be very easy to migrate your existing SQL to Hive. All right. Now we will go into the little bit more details. So there is something called meta store. Why do we require meta store? Because that's where it stores the data. It stores the definition of tables. All right. It allows you querying the HDFS file in HBase. These are the limitations. It does not provide you update, insert, and delete. It can generate new tables. It's not suitable for OLTP. Online transaction processing is not suitable for that. Yeah, it does follow an ANSI standard. That's correct. It does not, though it does not provide you update, insert, and delete, but it can generate new tables just like this. And is not suitable for things like where queries require a really fast response. Okay, because the query in Hive is going to run at least for 5 seconds, minimum 5 seconds. And generally in traditional SQL systems, the query response times is 200 milliseconds, 300 milliseconds, right? All right, so here the important part to understand is in Hive you have, one is Hadoop, where there was job tracker, task tracker, file system, and all that. There is this driver which converts a given query into MapReduce. But for converting, it also uses something called a metastore. What is a metastore? That's where it will be storing the definitions of table. You will be creating tables in Hive and make sure that these tables will be storing the data on HDFS, okay, but the metadata is stored in something called metastore. What is metadata? The definition of table. These are my columns, these are my data types, this is my database name, and so on. Okay, that will be stored in metastore. All right, now we have got, this is my driver is the one which utilizes metastore and generates MapReduce out of my query. Now, who all can send the query to the driver? There is a command line interface. Where is the command line interface? You can just go here and say Hive, or you have the Hive web interface. So when there is a service from remote, they can hit the Hive web server and then they can query directly from the browser. Okay, or they can use a directly REST interface. Now on top of the driver, it does also has something called a thrift server. What does thrift server do? Okay, is my voice very feeble to everyone? All right, so how many of you are aware of what is a thrift server? Okay, all right. Now basically when you build in today's time, when you build a service, you have to, let's say you are building a phone service. Okay, one way to access your service will be from the browser, right? The another way to access your service will be from the, maybe your some C program API. Basically the API would be in C, it could be in C++, it could be in Python, it could be in Java, right? So if you build a service, these are the clients These are the clients of your service are going to look like this. All right. Now, there are around 100 languages, or maybe more. There are around 100 languages, which basically, is the screen still freezing? Let me turn off and turn on the screen. All right. So there are around 100 languages. You cannot create 100 different APIs for every language. Okay. You cannot create 100 different API for your service, right? So what will you do then? You are a small startup. You just built a product, built a service. You wrote a basic API which people can use. Now, there are many people who want to use your service using this client. What will you do? Okay, that's where the thrift layer comes into in between. So you write your thrift layer, and so you have, let's say your service is this. Okay, there are many people who are trying to use your service from many places. Okay, they're trying to call your server. Okay, one is using C, other is using C++, and other is using Java, and so on, right? And instead of doing this way, what you do is you create one more level of things. Okay, what you do is your logic stays to one side. Okay, now here what you do is you create something called a thrift layer. Okay, this is our thrift. Okay, now thrift layer you just implement in one language. And thrift will provide the interface in all possible languages. Maybe some other language such as PHP, or, or maybe Perl. So that's where the role of thrift comes into play. You only implemented your service in thrift, and rest was done by thrift and provided all the clients in all possible language in the world. All right, that's how most of the systems are built in today's time. So be it ODBC. Is the screen frozen still, Prithvi? What do you see on the screen? The diagram, right? Oh, the refresh rate is very slow. Okay, so I think there has been some upgrade these guys have done. Go to meeting, guys. In recent time, we are facing that one. All right, so it is clear now, right? What is a thrift server now? Now, by the way of thrift server, JDBC, ODBC, everybody can connect. All right. So even if you are working on something in Java or any other language, and you want to build a service for the use case in the organization, you will go for something like a thrift server. Okay, similar to SOAP, or basically for service oriented architectures, thrift is great. Thrift is from Twitter. All right, now here we have, very quickly, this is how the word count example looks like in Hive. Do you see that? There is, from starting, first we copied the file onto the HDFS, then here is the big SQL. What does it do? In the beginning, it splits the line by space, and then it explodes it, meaning it creates multiple records out of an array of words. Afterwards, it does a group by on the word, and then it saves it into the word counts, right? It's fairly straightforward. How to start using Hive is you SSH onto the server student at Hadoop 1. No big data, or here, and then you can start using. All right. So you can either use Hive just like that, or in case you have just one query to execute, you can say Hive minus E and give the query. If you have the full script, a list of, say, list of few commands which you want to execute one by one on Hive, then you can write that into a file and then provide that path here. Okay. All right. And a simple one would be create table, select star from X, drop table X. Now here you must have noticed few things. One, Hive is not just a client. Pig is just a client. Pig is just a client. Hive is not just a client. Hive also has something called Metastore. Hive also has something called a server, which is thrift server, which is listening to queries from users. And just to confirm this hypothesis, you can have a look at our Ambari. Under Ambari, if you go to Hive, it will show you what all services are running and what all services are down. Under that, you can see that there is a service which is running for Hive. Okay, so there is something called Hive server. The other one, so answering to Morgan's question, you can go to this location. Okay, there are multiple ways to execute query. One is from this interface, from command line, the way I have started. The other is you go to Hue. Under Hue, there is a way to execute queries. Now you can see that under Hive, the Hive server 2 is there, MySQL server is there, Hive clients are there, Hive server 2 is stopped. Okay, and it did not impact us because we were not trying to access the thrift service, and we were basically using the local command line. Okay, now if you want to see what is there in the H catalog, you can go here, or you can go to Hive here, the first one. Now you can see that these are my tables, right? These are my tables. These are my databases. These are my databases, and these are my tables. Under each database, whatever tables are there, there are here. All right. So let me try to unplug my. All right. So is the voice still low, Santosh? So Murugan, can you see the tables? Now these are the list of databases. You can create a new database, and you can also go into one database and you'll see all the tables. Click on one, you will see the data here. You can say sample, or you can just say browse data. Okay, it's maybe taking a little bit of time. hmm Something is wrong with this. All right, so let's go back. hmm There's some other error. Can we query the metadata DB? Yeah, you can query. You can just connect to MySQL locally and then see what's there. All right. All right. So this is the general diagram of how does it work. Okay. So let's start with simple one. All right. Now on the Hive command prompt, let's talk about a bit about Hive command prompt. The way we had a command prompt for pig, we also had a command prompt for Hive, and here also we can execute the file system command such as dfs, and we can do that. Put the semicolon and then you will see the results. Okay. Similarly, if you want to load an existing SQL script, you can also do a source. Okay. All the commands start with double dash. You can set the variables in the environment and then start using it in the queries. Okay. Also, if you want to execute a local ls command, you can put exclamation and execute the local ls. All right. Now, the data types in Hive are the data types in Hive are based on sort of a union of almost all the databases. Okay. Almost all the databases, the union of those data type has been put it because Hive tends to be compatible with most of the databases. Okay. So these are the one, and in the bracket it shows that in what version of Hive introduced that particular data type. Right. Now, other than the basic data type, which is you saw that numeric one, boolean, string, date time, there are complex data types such as array, such as hash map, or such as a map key value pair, or such as a struct. A struct is an object where keys are predefined. While in a map is also looks like struct. Map also looks like struct, but map does not have the key value pairs. Any fixed keys, it is flexible. Union is an interesting database. Hello. Now can you see the video? I had turned it off. Maybe it will take a little bit more time. It has not yet come. Strange. Okay, so it's actually fairly slow. What could be the reason? I'm not able to figure it out. Strange. All right, so I hope the voice is clear for you. So last few slides, nothing much. There are data types in Hive. Before that, you can run the basic HDFS commands on Hive. Okay, and then you can also specify various environment variables and all that. Okay, now this is what your table would look like. Hello, hello. It shows me that audio is not connected, although the audio is very well connected. Can you hear me clearly? All right, all right. So the basic data type is very common, and you would know int, string, date, time, and all of that. Now the complex data type. Now the complex data type is an array. Array is an array of objects, array of elements, array of any other data type, maybe array of maps. And a map is key and another complex data type. So we can have map of maps and map of arrays or whatever. Struct is just like an object where keys are fixed. That these are the only keys you can have in this object. While union is out of all the parameters of union, all the data types, there will be only one data type value at a time. Okay. For example, if you have an authentication system, your employees can be authenticated by Facebook, Google, or email. Okay. All these three things you would like to store in a single column because at one time you will be storing value in one of these three. That is union. Next is how to see the databases. You can go to the command prompt and say show databases. It will show you all possible databases that are there in our system. You can see show databases. You can see there are so many databases already created. If you want to create your own database, ideally you should create your own database. You should say create database, create database and say Chandra. Okay, now it will create the database for Chandra. Okay, so you can't see my screen. What do you see right now? Is it screen number for 15 or 14? All right, now you can create the database using create database, your database. Describe database, you can see All right. Oh, this is horrible. Now, what do you see? What? TMP, HDP, HDE. What is this? All right. So looks like it's horribly slow. Now, six, slide number 15, right? Now, okay, so you can use the standard commands for creating databases, showing the list of databases, and describe the database. In case you want to see the database in the command prompt, you can set this particular variable to true, and it will start showing the database in the command. You can drop a database as well, and you should create your own database so that you don't mingle up with other people's table. Okay. Next is similar to SQL table, you can have show tables inside the database. Now, do you see slide number 16? Okay, so show tables shows you the list of tables. Select star from my table gives you the records from your table, and describe my table gives you the details about your table. In case you want to see the more detailed version, probably the last command is the best one. Describe formatted and you say my table. Okay. All right. So the important part to understand in case of Hive is there are two kinds of tables. One is internal tables, other is external tables. Internal tables, the only difference between internal table and external table is that when you delete an external table, it does not delete the data, it only deletes the metadata. Metadata means the table description. When you say show tables, the table will not show up. Okay? Now, if you have an external table, the data will not be deleted when you drop a table. But in case you created a managed table, when you say delete a table, it will delete the data as well. All right. So every Hive table has got two parts. First part is metadata, like what is the column, what is the database. All of that is metadata. What are the data types? And the second part is the actual data. Actual data by default is stored in the HDFS file system. So the metadata is stored in MySQL database using metastore, while the actual data is stored in HDFS. Yeah, so Murugan, the describe command does not show the details. That is why there is something called describe formatted. All right. So the only difference between managed table and external table is that when you delete a managed table, the metadata, the actual data is also dropped, and if you delete external table, actual data doesn't get dropped, only the metadata vanishes. Okay. As a thumb rule, I try to create an external table in case in the first line where I'm loading the data from an external service. So that in case I delete a data by mistake, in case I delete a table by mistake, my underlying data should not get deleted. So as a thumb rule, prefer external table over the managed table. That's all. Okay. Next is the Hive meta store, right? As we saw that we have to create tables, right? We have to create databases, we have to create table, like we created an employee table here in the slide number 14. Let me just wait for a minute until the slide 14 reflects. So let me know when the slide 14 is on your screen. All right, slide 14, you can see that we created a table. We said create my table employees and we specified this data. So this information goes into Metastore. Metastore is what that stores this information. Okay. Metastore has what all DBs there, what tables are there, what are the table name, name of table, number of columns, partitions, etc. Okay. The next is, so you can see the example that this is how you create a table. You can just copy this and paste it on the command prompt and it will create the table. You can see that. You can see slide number 19. So create table NYSE daily. You can say these are my now, or still 18 is shown. Now still 18. All right. So this is the table. This is how we create a table, and then also tell Hive that this is where our data is located. In the last line, we say location data slash NYSE daily, right? So whenever we create this table, the data would go into HDFS at this location. All right. So that's how we create a table. So this metadata goes into Metastore. The data goes into data slash NYSE daily in the HDFS. All right. Now, so do we have to provide the file, or is it okay to provide directory if we have multiple files? No, actually the data of a table is actually stored in a folder. It's not a file. Okay. As and when you keep on adding more and more files or more and more data to the table, you'll keep on creating more and more files into that folder. So Prithvi's question is, can we have index and keys in this table? Not really, not really. It does not provide you a way to create index. All right. Location specifies the source or the destination file. Location specifies where your data is stored for this file, this table. If the data already exists, then when you say select star from this table, it will start giving you the data. This is where the data is actually stored. You can think of Hive as, simple view on top of the file. On top of your HDFS file, you have, okay, now I will show you. Yeah. So here you will notice one more thing in the slide number. Where did it my Okay. In this slide, you will notice one more thing called row format delimited fields terminated by slash t. It says that although although we are creating this table, we're storing this metadata, but actual data is going to get stored here. And how is Hive going to understand it? By the way of separating the records by tab. Okay. Fields are separated by slash t. Make sense? So whenever you do insert into this table, this file is going to get overwritten. Okay. And when you are going to say select star from NYSE daily, the data from this file is going to get displayed to you. And how, in what format? Using these fields. All right. A tabular format with these are the column. So Roshan, okay. Now Roshan's question is, does it convert the text data into existing document file into tabular format mentioned in the table definitions? Does it convert text data into existing doc file into a tabular format mentioned in the table definition? So it doesn't do any translation of the data as such. Okay. Only while presenting the data, it will pick up from this HDFS file and will start displaying it to you. Okay. All right. Although this mechanics is changing, they in the next version they are planning to change this mechanics, and Hive will start behaving like full-fledged database. Okay. So you can try this. Once you have created the table, you can load the data into the table using load command. Okay. We will show it on the next time. Okay. Till then, please finish the assignment from of pig. Okay. You will see the assignment of pig in the learning management system, and please try to finish that part. All right. We'll see you on next Saturday, and we'll take it further from this point onwards. All right. Bye bye. I'll try to see this video thing. Let me see how can I resolve these issues. All right. Thank you very much. See you on the next week. You too. Have a nice day. Bye bye.